In this video, we're going to talk about some key terms in statistics. I'm going to just kind of briefly go through these key terms and leave you to work on memorizing them. But the most important terms we want to kind of know is that the group that we're talking about, the group we're studying, that's our population. And of course, that varies depending on what we're interested in. We could be looking at the population of Oregon, or we could be looking at the population of our college. It just kind of depends on what we're looking at. A sample, which is the third definition here, is a subset of the population being studied. And these two things are really important because we're using samples to look at our population, because maybe it's difficult to look at the whole population of Oregon, but maybe we could look at a sample of that population. So a statistic, which is this fourth one here, that is a numerical summary of the sample. So when you say 60% of Oregons support their current state representative, okay, I'm making that up, by the way. I don't know what it is. That probably came from a sample, a group of people that they went out and surveyed. A parameter would be the actual percentage of the state that supports their state representative, okay? Descriptive statistics, that's when we're describing the data, that's summarizing, organizing it, making it look pretty, putting it in tables and graphs. The inferential part of statistics, that's the part that's more complicated. That's when we're going to kind of study in the last part of the class, analyzing the data and inferring things about the population based on the sample. I just also wanted to point out the word variable in statistic right here does not mean unknown. In statistics, a variable is a characteristic of individuals in the population. All right, so two words that often come up, mean and proportion. Just want to kind of highlight those really quick. Often when we see the word mean, we think average. That's what we associate to average, the mean. All right, but there are different ways of averaging data, and we'll talk about that later. But an example of mean would be like kind of what most students know. You take 3 tests, okay? And let's say your scores are 86, 75, and 92. And then you want to find the average of these. That average would mean that you would add up those 3 scores and divide by 3, which, by the way, just so you know, comes out to 84.3. That would be an example of mean. But proportion is different. Proportion is usually dealing with a percentage or a fraction. So if I told you that in a class, 18 out of 40 are women, that's a proportion of women. Saying 18 out of 40 could be thought of, by the way, as 0.45 or 45% of a class that's of size 40 that has 18 women are women. All right, so those are two terms that we use a lot in statistics. Mean is proportion. It's a way of kind of summarizing data. And so we want to kind of be aware of that before we get going. All right, so let's look at this example. We're going to define all of these for this example here. We want to know the average amount of money first year college students spend at ABC College on school supplies that do not include books. So we're not looking at books, just supplies only. They surveyed 100 first year students at the college, and then they gave us some of the sample, like what some of those responses were. They gave us 3 of those responses, 150, 200, and 225. Okay, so the population we're looking at here are first year college students who are probably going to spend more because they're kind of just getting going, figuring out what their major needs are, and settling down. So first year college students. At ABC College. And we'll be specific to the college they're referring to. Some colleges, like Harvard, might be different. All right. So in this case, the sample would be those 100 first years that they pulled. Helps if you spell students, right? There we go. The parameter would be the mean. or average amount spent on school supplies. So average amount spent on school supplies for all first years. And at ABC. Here, I'll just put ABC. Okay, so it's talking about all of them. That's the parameter, the mean for all of them. If we were to find out that information for every single one, the statistic would be the average for the ones we surveyed, those 100 people. So this would be the average amount spent for 100 surveyed. And I'll go ahead and kind of shorthand that a little bit. All right. The variable in this. So the variable that we're interested here in is what they're spending. Okay. How much is going to be spent. So when we talk about the variable, the characteristic we're studying, we do use often X or Y to represent that. And we typically do a capital X or Y. So this X would represent a literal money amount. Okay. So dollar amount spent on supplies. All right. Now the data itself is going to be dollar amounts. Okay. So these are the actual dollar amounts. And they kind of gave us an example of that. So we'll go ahead and list that. For example, the $150. Oops. That does not look like a one there. Sorry. $150, the $200, and the $225 would be types of data we would see for this. Okay, so let's look at another example here. So as part of a study to test safety of automobiles, the National Transportation Safety Board collected and reviewed data about the effects of automobile crash on test dummies. Here's the criterion they used. The car was going 35 miles per hour and the location of the driver, which is the test dummy, is in the front seat. Okay, so we want to know the proportion of dummies in the driver's seat that would have had head injuries if they had been actual drivers. We will start with a simple random sample of 75. So what I love about that is we already know what the sample is, right? So the sample are those 75 cars that they looked at, 75 cars. But clearly they did this on a lot more than 75 cars, right? They did this on quite a few more. So that would be the population they're looking at. All of the cars containing test dummies in front seat. And if you really want to get specific, you can say going 35 miles per hour. All right. So the 75 cars would be our sample. All right. So the parameter in this case, they're looking for the proportion of those drivers who would have a head injury. Okay. So the proportion of all, and I'll put drivers in parentheses, who had head injuries in all cars. So again, emphasizing all the cars, all the ones that they did this on. But the statistic is the proportion of those 75 drivers that had injuries. Who had head injuries. All right. So the variable in this case, it would be the number of actual drivers or, these test drivers that actually experienced some sort of head injury. What would have been a head injury? Okay. So this would be the number of drivers with head injury. And here I do want to note That's referring to the sample, within the sample. So this would be a number 75 or less. Okay, so this X, this value is the number of those drivers, those 75 or less. All right. And the data we'd be looking at in this case would be whether they had an injury or not. So this kind of data is a little bit different. We're looking at like categorical data, meaning like it's not a number. We're saying they had the head injury or they didn't have the head injury. So it's injury or no injury. So when we have data that's kind of summed up like that, they call that kind of categorical data, and we'll talk more about that in future sections. But that is it for this video.